Hello! So in this video we're going to be looking at inclined planes. So this is forces outline, and we're going to be looking at that set 4E section. Okay? So let's go ahead and jump into it. So problems with inclined planes are different from horizontal surface because we are going to shift our axes. So normally we just have something that looks like this. For the inclined plane, we have this inclined plane here. We're actually going to shift our axes so that we have an axis that is parallel to the inclined plane and perpendicular to the inclined plane. Okay, so if I draw a free body diagram, you're going to have mg, obviously is just straight down, right? Then you have fn. Fn is always perpendicular to the surface, okay? And then you might have something like ff. There could be an applied force up. You could also have an applied force down the inclined plane as well. But you'll notice that mg is actually going to have two components. Okay, so that blue component is going to be mg, and then that is going to be sine theta. The green component is going to be mg cosine theta. Okay, now remember we talk about how usually cosine goes with the x and sine goes with the y. This is kind of an example where it's a little bit different. Okay, if you ever get stuck and you can't remember, just remember that this one needs to equal 0 when the theta equals 0, right? Because if the angle is 0, it's just a flat surface, in which case there is no gravity force that's kind of in that side-to-side area. So sine of 0 is 0, so mg sine theta, we have to use sine theta for that down the inclined plane part, okay? Another way you can think of it is it's pushing down the inclined plane, down, up, down. That's kind of like the y direction. Okay? So let's go ahead and try this first question. It says a block with a mass of 5 kg is being pulled up an inclined plane that is at 35-degree angle. The block is being pulled with a force of 50 newtons, but there is a 15 newton of friction being applied to the block. What is the acceleration of the block? So let's go ahead and draw a free body diagram. Remember, that's our first step. Remember, mg is always straight down, okay? Then fn is always perpendicular to the plane. Then we have it being pulled up with a force of 50 newtons. And then we also have a force of 15 newtons of friction. So that's my ff. This is my fa. Okay, so like we've done before, we can set up an fy and fx chart. So we have a couple forces in the x direction, a couple forces in the y direction, but remember we're going to have to split up our mg. So in the blue side, we have mg sine theta, and then in the green side we have mg cosine theta. Okay, so let's go ahead and put things in. So in the x direction, that's sort of this direction, x, and then we have this side, that's y. So in the x direction I have 50. I have minus 15, minus because it's backwards, and then I also have a minus mg sine theta. Okay, and then in the y direction we have a fn, and we have a minus mg cosine theta. So normally in the past we've seen that fn just equals mg, right? For inclined planes, fn is going to equal mg cosine theta. Okay, so if it's just on a flat surface and there's no up or down additional forces, then fn will equal mg. But if we're on an inclined plane and there's no up and down extra forces, then we know that fn will equal mg. One of the ways to think about fn is that fn is just what you see on a scale, right? So if you think about a scale, you started tilting a scale to make it an inclined plane, it's going to end up with a less number on your fn, that smaller number on the actual scale value. And then if you keep rotating it, so you're rotating it, at some point you get to this horizontal surface. Now your scale is going to have no value, right? Because it's nothing pushing on it. Okay? So I want to find my acceleration. You'll notice that the acceleration in the y direction, as we've often seen, is just 0. Okay? Now that means I just want to set up fnet for just the x direction. So I'll have fnet equals 50 minus 15 minus mg sine theta. Okay? Now we need to plug in for fnet. So I'll have ma equals 50 minus 15 minus mg sine theta. And then we can go ahead and plug in values. So then I have 5a equals 50 minus 15 minus 5 times, I'm just going to use 10 for g. Remember, this negative sign here, we're already putting a negative for that g because that has to do with the direction of the actual vector here. So we don't need to plug in a negative value for this g here. We just plug in a positive value. And then sine of 35 degrees. Okay? And then you just would divide this by 5, and that would give you a. Okay? And so you can do the algebra later, but the important part is sort of the setup part. Let's try one more example problem. So it says, a 4 kg bucket of water accelerates down an inclined plane once it is raised to an angle of 40 degrees. There is 9 newtons of friction also being applied to the bucket. What is the bucket's acceleration? Okay. So once again, our first step is to just draw a free body diagram. So I have mg straight down, then I have Fn perpendicular to my inclined plane, and then I will also have friction. Now, because it's moving down the inclined plane, right, my velocity is down, that means the friction needs to be up the inclined plane. So this is one thing where you really need to be paying attention to the question, because it could be different, right? It could be that your friction is up the inclined plane, it could be that your friction is down the inclined plane. It will just depend on the actual situation you're in, right? If it's moving down the inclined plane, friction should be up. If it's moving up the inclined plane, friction is down. The other thing to think about is potentially where it might move, right? So for example, if maybe I was pushing up the inclined plane and it wasn't moving, well, the way it would move if I push harder would be up the inclined plane, right? So friction would be down in that direction. Okay, so it can be a little tricky sometimes to figure out which direction. Just think about which way you're expecting it to move, and friction should be in the opposite direction. Now, once again, we need to split mg into 2 components. So my blue component is just going to be mg sine theta, and then my green component is mg cosine theta. Okay. Now, once again, we're going to make an xy chart. In the x direction, I'm going to have 9, okay, and then I'm going to have also minus mg sine theta. Now, I'm actually going to make a change here. One of the things I want to do is the direction of acceleration, I want to make that positive, okay? You could potentially set it negative, but in general, it's always best to set the direction of acceleration as positive. So we're going to make this a -9 and a positive mg sine theta, okay? And then in the y direction, we have Fn, and we have mg cosine theta. Now, once again, I'm not moving in this plane, right? I'm not moving into the inclined plane or floating off the inclined plane. So I know that Fy equals 0. That also tells me just that Fn equals mg cosine theta. Okay, now I just need to set up my Fnet. Fnet equals mg sine theta minus 9. Then I need to plug in for Fnet, so I have ma equals mg sine theta minus 9, and then I just need to plug in numbers. So it's a 4 kg, m equals 4 kg, so I have 4a equals 4 times 10 sine of 40 degrees minus 9, and then for my last step, I would just divide both sides by 4, okay? So I have something like a equals 4 times 10 sine 40 degrees minus 9 all over 4, right? And then obviously you can do that algebra, okay? And so that's kind of what we're doing. If you have questions, make sure you let me know, and hopefully you are able to kind of get the basics of inclined planes. Thanks so much.